Hello, good evening, all. I'm Shani Burman. Today we are going to be live for the problem solving session number 8 for the course named Chemical Crystallography, which has been taught by Professor Angshuman Roy Chaudhary from IISER Mohali. The exam date for this NPTEL SWAM course will be on 28th October. I hope all of you have registered for the exam. Now I am the course TA. I'm one of the PMRF scholar from the Department of Chemistry, IIT Hyderabad. Each Friday from 6 to 8 p.m. I'm taking this problem solving sessions. Now on week 8, sir has taught us how to interpret X-ray data, how to deal with the raw data we get from the single crystal X-ray diffraction diffractometer, and then how to solve the single crystal structure in both Apex and OLEX softwares. And also regarding the CCDC, sir has taught us how to check the structures and how to get the basic information about the structure, how to find out how novel your compound, whichever you are synthesizing or whichever you are getting. That's all. So moving towards to the problem solving session. Firstly, I have taken the latest quiz of quiz 7, which the deadline of the quiz to submit the answer was on 13th September. So I'll be proceeding first with solving the answers of the quiz number 7. Now the first one is the structure factor is not dependent on. Please note that. Just say. Please note that the question has been asked which is not dependent. Sometimes we may read the questions as the in which parameters or in which factor the structure factor FHKL is dependent on, but that's not the question here. The question here is not dependent. Okay. So firstly, it will be easy if we write just the expression of the FHKL in general. So FHKL is equals to f e to the power 2 pi I hx plus ky plus lz. Now here, f is, this is structure factor, right? It's written here also. Now f is atomic scattering factor. It's already been given in here in option A. Now the phase angle. Now if HKL, we also write if HKL as amplitude scattered by the atoms present in the unit cell divided by amplitude scattered by one electron. Okay. So this also gives the phase angle of the scattered wave. And from here, this expression only you can say the HKL. If let's say if it is 0, 0, 1 plane, then we'll put x equals to 0, 0, 0, y equals to 0, z equals to 1 here. So the structure factor is dependent on atomic scattering factor, this one, then the phase angle, and also the plane HKL, this ones. So the answer will be unit cell parameters. It doesn't depend on the unit cell parameters A, B, C or alpha, beta, gamma. Now the second one is which of the following statements is correct? Structure factor is Fourier transform of electron density. Okay. First, we'll see the relation between the FHKL is structure factor and the electron density. So, FHKL is the integration of in a volume rho xyz, this is the electron density, e to the power 2 pi I hx plus ky plus lz, and integration on dv, like total volume, right? So FHKL is Fourier transform, structure factor is the Fourier transform of electron density. This statement is correct. Here also the statement is there. So is not, so this is not the, are not related to each other. No, they are related. So these are the two options we can omit. And this is the possible options. Now, rho xyz can also be written as 1 by volume of summation of FHKL expression e to the power minus 2 pi I hx plus ky plus lz. Right. So electron density and structure factor both are related to each other by Fourier transformation. Electron here in the first option it's given electron density is Fourier transform of structure factor. Yes, it's right. Here it's not. No, it's wrong. So this is also wrong. So the final answer would be this. Now the next one is, which among the following will be the systematically present reflections? Please note at systematically present, not absent. Okay. So the conditions for FCC lattice to be systematically present is, it should be all odd or all even. HKL, all odd or all even. Right. So among the options, here it is no. This is not will be the answer here. 1 1 1 2 2 2 2 4 6. Here is even odd. So this is the option. Okay. You should keep it in mind always. Now, which method is used for structure refinement? Direct method, linear least square, Patterson linear least square method. Direct method is for structure solution, and for heavy atom, it's Patterson method, like we obtain, and linear least square is for structure refinement. Now, which statement is true for rotational photograph for a crystal? In previous lecture class also I have answered this. Rotational photograph is always centrosymmetric for all crystals. Now, different next question is, different planes have different structure factors. Yes, because if HKL depends upon HKL, so for different planes we have different HKL values. So different planes must have different structure factors. Now, in a body-centered lattice, the reflections are systematically absent for H plus K plus L is odd. Should be odd, right? So, like, I'll just do it. It should be always odd. So the answer is wrong. Hmm, false. So the next one is, yeah, next one is during the data collection process, the crystal should always stay in the beam. Yeah, of course. Otherwise, how will you get the correct data if the X-ray beam doesn't hit the crystal? You won't get the correct data, right? The next question is, the data collection process can be stopped in between the process of collecting frames? Yeah, you can. The next question is, a data of 50% completeness is acceptable for IUCR publication, International Union of Crystallography. Now this is at least it should be 90% for a but like to publish a paper, right? So it's not correct, so it will be false. Next question is, what does pig hunting do? So these are this is from the practice set of the week 8. Now, what does pig hunting do? Pig hunting reads all the diffracted images and identifies the diffracted beams from the large number of image that has been recorded, and those data or those images have a varieties of spots with different intensities. So peak hunting helps us to detect the actual diffracted images and identifies the diffracted beams. Now the next one is shell Excel is for structure refinement. For structure solution, we use shell XS or XT. Okay. Now the next one is, which of the following is not true? Mercury enables us to check intermolecular interactions. Yes, it does help. Enables us to check intramolecular interactions. Yes. A particular type of interaction can be specified in mercury. Yes. So what is left? This one only. The interaction can be changed using mercury. No, those cannot be changed. So this is the right answer. Because the question it has been asked which is not true. Now the next one is, the unnecessary reflections can be removed from the data. Yes, of course. That's how we get the actual data. Otherwise, it will be very problematic, right? If there are many junk in the raw data. Next one is, short contacts are less than the sum of van der Waals radii. Okay, yeah, it's true. And this we can be detect from mercury software, right? Now the next one is, which among the following statements is true about the negative thermal parameter? Okay. um, the atoms are wrongly assigned, the occupancy is not assigned properly, atoms is not refined independently. Okay, the answer will be, the atoms are not refined independently, uh, because negative thermal parameter, what does it do? Any thermal parameter, it indicates like isotropic thermal vibrations. So negative thermal parameters suggest the anisotropic thermal vibrations. Uh, to be is the atom doesn't vibrate uniformly in all directions, right? Instead, it has a tendency to vibrate more along certain axes or directions. So means like negative thermal, if let's say for each atom it's showing negative value, right? Negative thermal parameter value. Then it means that these specific atoms are not spherical but elongated along specific directions, right? Because this information is very important for like to accurately model the atom's position in a crystal lattice. That provides, like ultimately that will provide the crystal structure, right? So if atoms are not refined independently, then we may get negative thermal parameter. Now, what metal does a beam stop has? It has lead. We use lead. Here it is. Because you know what? Mm, see, what happens, like when you like eject X-ray from the source, like it may be copper or molybdenum, whatever it is. Now the X-ray source heats here the crystal, right? And the like and the being the X-ray got scattered in various directions. Like so, some of these X-rays may travel toward the to the detector and interfere into the actual diffraction pattern of the crystal. So that is not wanted. That is not desired, right? So by placing a beam stopper, what does it do? Lead will stop the beam to hit directly to the detector. What does lead do? Lead absorbs some of the X-rays and that it effectively blocks the scattered X-rays. Right, so we'll get a more clean, background noise free and accurate diffraction pattern, and that will be easier for us to get like actual data or actual information about the crystal. Now, why the atoms are elliptical in shape and not spherical? So it is because of the thermal motions of the atoms. Okay, so because of the thermal motions, that an ellipsoidal models, the size and shape of the ellipsoid convey the information about the uncertainty in the position of the atom due to thermal vibrations. So this is very crucial to accurately determine the uncertainty in atomic coordinates and to understand the dynamics of the crystal. So we use ellipsoid atoms rather than the spherical ones. Next one is what is true for dynamic and static disorders. So dynamic disorder happens due to the thermal motions of the atoms, and static disorder happens due to the orientation of the atoms inside a crystal lattice. Now, dynamic disorder can be reduced with reduction in temperature, because if you increase the temperature, we all know the atoms starts vibrating more, like the thermal motion will be more. So then the dynamic disorder also gets increased. So to reduce the dynamic disorder, we reduce the temperature, but static disorders remain unaltered with change in temperature. Okay, so this will be the option. Now the next one is the packages used for structural solution and refinement as shell XT and shell XS. So structure solution for shell XT, refinement for shell XS. This is the question, right? So structure solution we do with what I just told, right? For XS and XT both, and for refinement we use XL, not XT. So this is wrong. Now the next one is addition of hydrogens do not have significant impact on the R1 factor. See, addition of like we first assign all the major atoms. Later, after several times of refinement, we add the hydrogens. But if we add hydrogens and refine it again, the structure in OLEX, you will see the R1 factor will also get reduced. So adding hydrogens also impact on the R1 factor value. Okay, so this is wrong. Do not have it's written, no? So it's wrong. So it have significant impact. Now the highest Q peaks represent atoms in your structure which are not assigned during the solution phase. Yes, it's true. Now the next one is in the following image representing two Q peaks, Q1 and Q2, and whatever it is. Okay, it's not Q2, it's written as Q17. Okay, Q1 corresponds to a large unsigned electron density, while Q17 arises from a very low unassigned electron density. Yeah, you can scroll the mouse and you can reduce, and you can omit this nominal electron dense Q peaks. Okay, and if you assign let's say C, N, F, it will get colored like accordingly. This because these are much electron dense. Okay, so yeah, the statement is true. Now the next one is the alert. This one, plat 112, plat stands for platen, and the alerts got generated is alert 2B. ADSIM detects new pseudosymmetry means it means detects new pseudosymmetry means it will detect additional symmetry, right? So this is the option. So it means additional symmetry element detected which is not incorporated. So we have to refine it again, and maybe we have to like check into the space group or. So the next one is the file type which should be opened during Chrysalis Pro for single crystal data handling is .par file we use, right? .par file because yeah, mm, whenever we use in Crystal Alice Pro like the with the omega width of zero point 0.3 degree, we generate .par file, and this only can be opened for Chrysalis Pro software for indexing and data reduction of the single crystal data. This is the option. Now the next one is which among the following files contain the experimental structure factor information? Experimental structure form. Okay, factor information. Structure factor. It depends on the HKL. So the file name is also like .hkl. Okay, because it's a Fourier transformation of the electron density to get the calculated of HKL for all reflections. And the file we got generated is saved as .hkl. Now the next one is if a crystal structure indicates fraction value for Z prime, then what does it indicate? Okay. Uh, More than one molecule in the asymmetric unit, presence of solvent in the asymmetric unit, some symmetry element of the crystal structure is passing through the molecule, presence of a pair of ions in the asymmetric unit. So, okay. So first we have to understand what is Z bar, Z prime. So Z prime refers as multiplicity in multiplicity of the asymmetric unit, or you can write it as number of independent molecular entities within the unit cell, right? In the unit cell, I'll write in the unit cell. So it's very important because it provides important information uh, about the lattice or the unit cell. Okay. So if Z, what if Z prime equals to 1, it implies that there is only one unique atom or molecular entity in the asymmetric unit of the crystal. Or you can say that it contains the contents of the unit cell are entirely described by a single molecular entity, right? But if it is indicates fraction, like if it indicates like zero point 0.5, then you can say that it is half of the structure, means some symmetry elements of the crystal structure is passing through the molecule. So we are not like it's not considerable, and we are getting a fractional value. So this will be the answer. More than one asymmetric unit means Z prime will be more greater than 1, but in integers, of course. Now the next one is which Among the following is, achha, I'll just tell one thing. So Z, what does Z and what is Z prime? So Z is number of formula units, right? Number of formula units. Formula units means it can be molecules, molecules, ions, or any other entities like molecular entities. So this can be determined by Z. Okay. Now the next one is which among is the following is used to view the molecule and packing of the molecules. Yeah, it's mercury. Because in Chris Alice Pro we solve it and like this is one software and share access is one of the like you can say it's one of the technique, right? We obtain and Winjix also the same. So mercury is for to view the molecule, like it shows you the about the structure information, the packing information, the atoms present, the bond information, the bond angle information about the powder. It's RD also it informs you. Okay, so mercury is the answer. And the next one is which of the following parameters should be fixed before starting the data collection strategy determination? Desired resolution and exposure time, desired resolution, law class, and target redundancy, law class, and exposure time. Desired resolution, target redundancy, and width of each frame. Okay, this is, I guess, the second one, desired resolution, law class, and target redundancy. Because like before starting the data collection, for single crystal X-ray, we must consider about the crystal quality, crystal size. We all know wavelength of X-rays, detector choice, detector distance, exposure time, goniometry strategy, temperature, crystal orientation, then data processing softwares, data collection strategy like in which symmetry it's been taken like omega scan, phi scan, etc. Then data collection plans like in how many frames, like within how many frames you will collect the data, and in that only it comes the exposure time, then beamline access, sample mounting, uh, then sample environment like temperature and all. So it's very important to fix to fix the desired resolution before data collection, and also the target redundancy. It means that how many times the same reflection pattern you are getting. Okay, the like, number of copies of the same data set you are getting. So it's also important. So the next, okay, um I have taken all the questions from this week's practice assignment, last week's week seven's quiz, and also I have taken like few previous year questions, like, including all practice and quizzes. So this is all for the week 8. The week 8 assignment has already been uploaded in the portal. The submission deadline is 20th September, and that's on the Tuesday, coming Tuesday. Please do submit the assignments. Okay, thank you.